The ability to be able to easily add an OSI network to your current machine design can be a huge benefit to any machine builder. Let me show you how easy it can be. As you can see, here's my current controller and HMI panel. This is what we want to add, this OSI network to. So here's the master, an I/O block, a start-stop station, as well as a signal column. So that's the task. The first step is we come over to the actual hardware configuration. Here's the actual controller itself. I have the little filter box checked in the hardware catalog, so that means only the available parts that go in that rack are available to us. I can easily find it. It's the OSI master. Here it is. Give focus to it. Drag and drop it into the project. Now that's done. Let me go to the network view. And as you can see, I do have my current HMI and controller on Profinet, and I also have the OSI master. How about the field devices for the OSI network? Well, from a global library perspective, I have the ability to build up my entire network of all my field devices, including attributes. I can actually go back and save that to the global library, and every single time I have a new project with that exact same type of field device, I pull it in the project and you're done. So let's go to the global libraries. Let's go grab the first I/O block, drag and drop it in. If I want to change an attribute, just give focus to it, right click and go to properties. I want to change his address to 19A here. That makes sense, right? So let's go down and find the 19A address. Perfect. Attributes changed. Okay. How about the signal columns? Drag and drop him in. And then last but not least, start-stop station. Okay, so how about networking? Well, all I got to do is mouse over any one of these interfaces, drag it up to the master and let go. And let me go grab the next one. And as you can see, just like Profibus and Profinet, networking can be that easy. So now I've got my hardware done and my networks. How about code? Well, the first thing I'd like to do is go to the master, the actual controller itself, go down to properties. Let me go down to the system and clock memory bits, and what I want to do is I want to enable the clock memory bits because I want to use this later so I can actually pulse something. Enable it, and let me actually choose a byte here of 649, and as you can see, I have my clock underscore and whatever hertz I want to use for my pulses. I just need to remember that for later for my tags. Well, let's go back to the program blocks. Let's go add new block, organizational block, that's correct. Click OK. Accept the default name, that's no problem. Now I want to do a fill-in circuit here. Let's go grab a normally open contact, normally closed, as well as a coil. And let me go complete the fill-in circuit with another normally open and tie it in. So now my code is done. So just like the hardware configuration I had for my field devices in the global library, I can do the exact same thing for a tag database. I can create it once with the exact data structure I want to use, save that global library, and reuse that, creating engineering efficiencies in your daily work. Well, let's go to libraries, go to simple OSI tags, let's drag and drop it over to PLC tags. Here they are down here in the details view, so now I can start programming. Go drag and drop stop into the code, to the normally closed contact, start to the normally open, and go drag and drop motor 1 to the coil, go click on control and drag it back over, and now I have a completed start-stop fill-in circuit. How about actually doing some enunciation? Well, all I want to do is create some new networks. Go grab a normally open contact as well as a coil. I want to go over here to network 2 and just copy and paste this in a couple of times. I'm going to create 3 networks. Now that I've done that, I'm going to go give focus to them, and I want to use the motor 1 coil as anything to use in our normal code to enunciate. If that coil is actually pulled in, that means we're going to enunciate something, start, stop, whatever. Well, all I got to do is go grab him, drag and drop him in, and I want to go grab start, stop tag for this exact start, stop station, because you see I have one actual LED, and if it's high, you're going to see it turn on. If it's low, it's going to be turned off. So let's go grab that tag for our start, stop station. There it is. I can go back and grab the motor 1, click on control and drag it down. I can actually do that twice. So now I want to enunciate with our signal column. So let's go grab machine run, drag that over to our next coil, and then machine stop is our next one. However, I have to have the inverse state. for our yellow LED, and what I need to go do is change that contact to a normally closed contact. Okay, so I've got all my code enunciation. How about faults and diagnostics? Well, I've got one more line here. What I want to do is go grab the fault LED here, and it just happens to be the red LED in this particular configuration. And I also want to actually be able to pulse this red LED so you can see anything from a machine faulting perspective. What I want to do is go over here and go back to that clock bit, double click, use Smart Type and just type C, and there's our clock bits. I want to use 1 Hz. That's exactly correct. However, I have to use some kind of diagnostic block in order to get this to function properly. If I go back to my instructions, let's go down to Diagnostics, let's go grab the LED, drag it in front of our pulse, and what I want to use is the actual controller itself to actually generate this fault. So on the input side, just type in, with Smart Type, just type in S, there's the S7-1200, click Enter. And then the LED itself, I want to use the error LED, so let's use number 2. And the retained value is going to be error underscore CPU. And then I want to go back and define that tag. I want to make it an integer. Click Define. However, now I need to compare this against what's the normal and faulted state. So what I want to do is go over here and grab a compare, drag that in front of this pulse, grab this retained value, drag and drop it up, and last but not least, I need to figure out exactly what the states are of this LED. If I go down to LED block, just hover over it, go to Read Status, open up the Help menu. So the 1 equals permanent switched off. That's exactly what I was hoping it would be. Go give focus to it and copy that. Let's go back to our tags here. Double click on them. Go find the user constants. Name this exactly what we just had, so paste it in. 1 equals permanent switched off. Just move over. We want to use this as an integer. That's what it needs to be. To use Smart Type, just type I, click Enter, and 1 was the state. All I need to do now is actually split screen that and go find the compare value in our code. There it is. Give focus to this user constant, drag and drop it in. Now our code is complete. Just give focus to the main CPU and click the download arrow button. So now it's going to compile the fact that we have this new hardware configuration, including the Aussie network and all the field devices, as well as all the new code and the diagnostics that we just created for this particular system. The load button is now available for us to hit. Now it's going to load everything we just compiled and created for this Aussie network into the actual CPU itself. Once it's finished loading, we should see some green LEDs. I can click Finished. As you can see now, the entire system's up, fully functional. All I got to do now is go here and see I can hit the Start-Stop station. Everything runs the way it's supposed to. And in fact, I can go over and fault out the Aussie network. And this is the actual input for our Start-Stop station. It should fault. So the fault logic is working the way it should be. And the beautiful thing about this HMI is I went to Service Support and downloaded faceplates and function blocks for additional Aussie diagnostics. And this is completely free of charge. If I come over here to faceplate and hit Start Aussie Diagnostic, as you can see, I do have a fault on address 5. That is the Start-Stop station. And in fact, it's a hardware configuration error. So that means that the Aussie network is not plugged in. I was able to do this entire hardware configuration and all the programming in just a matter of minutes. Now that's engineering efficiency.